Okay, in this video I'm going to cover 2.5 programming languages and integrated development environments. Actually going to remember this time to do it full screen. Alright, so let's get started. This is the spec. It's short, this topic's short. You've got this first bit, which is looking at programming languages. There are two different types, high level and low level. You need to know the difference, and you need to know that they need to be translated into machine code, like binary, to run. You use a translator program to do that. You need to know what the purpose of translators is, which I've just told you. It turns high level languages into machine code. And you need to know the characteristics of a compiler and an interpreter. These are just two types of translators. You need to be able to compare them. That is probably the most common question that comes up about translators. The second part is they'll ask you about IDEs. Stands for Integrated Development Environment. It's basically the piece of software that you use to actually write code and run code in. So I'll talk to you about that when we get to it. Alright, so high level and low level programming languages. High level languages are like Python, C#, VB. They are easier for humans to understand and write. They use English-like words, for example, if and while. I've told you already the types of languages this relates to. I've told you already they need to be translated to machine code for the computer to run. They're translated by either a compiler or an interpreter. One instruction in a high-level language equals many instructions in machine code. So you could take an if statement, for example. It's a couple of lines when you write it, but when it's translated into machine code, it might be like 10 lines, 10 instructions. So mark scheme, it'll ask you for characteristics of a high-level language. Easier for humans to understand and write. That'll be on the mark scheme. English-like words, that'll be on the mark scheme too. So try and remember those things. We'll look at a couple of questions anyway at the end. Low-level languages. Now this is trickier for you because you haven't actually programmed in low-level languages, or the majority of you haven't. It's an A-level topic, programming in assembly language. But low-level languages actually include this thing called assembly languages and also machine code. So machine code we know is binary, just lines of binary. Assembly languages is slightly different. It looks like this add 10. So it's got what's called a mnemonic at the beginning, which is a word that kind of sounds like what it is supposed to represent. With add, it is the actual word, but you can see with sub, it's subtract is just sub, and store is str, and compare is cmp. You don't need to remember these, don't need to memorize them, but they're called mnemonics, and assembly language uses them. They're followed by an operand. So this is the opcode, the operation that it's going to perform. The operand is the second part of the instruction, and it's the data that it's going to perform that instruction on. A characteristic of assembly language: one instruction in assembly code equals one instruction in machine code. So that add will have a binary code, and 10 will just be converted to binary. So it's a 1-to-1 ratio between assembly code, or low-level code, in fact, low-level language, and machine code. They give you closer control of the hardware, they use less power, they execute faster, they're simpler to translate. However, they take a long time to write. So if you're having to write in this language, in assembly code, it takes ages. If you're writing in binary, it would be really easy to make mistakes. So not that many people do it these days, really. But that is low-level languages. I'll show you a question on that later. Translators. Computers only understand binary. A translator is a program that converts your high-level code, like Python or VB, into binary machine code. There are three types: interpreter, compiler, assembler. Now assembler actually doesn't work with high level code, it works with low level code. It is not on the spec, so don't worry about that. Interpreters and compilers are the two that convert high level code. This is the comparison, the question that you get asked a lot. Now a compiler is what you would use if you were using like C#, and it converts all the code at once into binary and creates an executable file like a .exe, and it just produces an error report after it's finished. Once it's been compiled, it's translated, so it's quick to run and it's easy to distribute to machines. Like you can just send them the executable. They don't need to have that compiler to run it. An interpreter is different. An interpreter converts one line at a time and then it runs that line and it stops if it finds a bug, so it's easy to find errors. So interpreters are very useful for developers like programmers because it will just run your code and stop when there's a problem. Python uses an interpreter, JavaScript uses an interpreter. Because it's having to translate as it goes, it's slower to run. The good thing about an interpreter though is that if you have the interpreter on your computer, you can run the code regardless of what type of processor you've got. This is kind of going a little bit into A level, but if you compiled some code using a particular processor, like an Intel processor, that code that's been compiled will only run on other Intel CPUs. It's processor specific. Whereas an interpreter, because you've got the interpreter there and it's doing it then and there, it will just translate it to the machine that you're working on. Anyway. So, IDEs, Integrated Development Environment. Think like Trinket for an online IDE, Replit, Visual Studio, PyCharm, VS Code. It's the environment that you actually write your code. Now the question that you get asked about this is, name some features. So first one, the easiest one, it contains a code editor and you use that to write code. And it might include color coding for keywords. Other things you can say, it's got a runtime environment so you can run your code and test it. It's got a debugger which will identify errors in your code. It's got error diagnostics which will give you reports on your errors. It has a translator which we know now converts your code into machine code. That's it. That's it for that whole chapter. Right, let's look at a couple of questions. Here's one. Give 2 reasons why some programs are written in low-level language. Quite tricky actually, that is. Machine code does not need to be translated, compiled, interpreted. So machine code is classed as a low-level language, so you could say it does not need to be translated. Direct control of hardware / memory, faster execution time, code can use less memory, code can program for specific hardware. That's a strange one, I don't know. Yeah, so difficult question actually. That. Describe the benefits of using a compiler instead of an interpreter when writing a program. Benefits of a compiler. Right, it's going to produce an executable. Once it's compiled, the program runs faster than the interpreted version, which you don't have to write, because that's what it means by it being in brackets there. The end users do not need a translator, so once it's been translated by a compiler, that's it. You don't need to translate it again, so people using the program don't need to translate it. Can be run again without retranslating, only needs to be translated once. Now, end users will have no access to the source code. If you're compiling it into an executable, the person who runs that executable can't see the code. Whereas if you're using an interpreter, they need the code. They need the source code. Source code just means your code that you've written. There we go. I think we'll leave it at that. Right, this one. A programmer uses a high-level language and an integrated development environment to create a computer game. Describe 2 advantages to the programmer of using a high-level language instead of a low-level language. Easier, quicker to create. Language closer to English. Uses keywords. Processor independent. Yeah, you can write higher-level language and then you can compile it to different processors. Whereas if you're writing in assembly language, you're writing for that processor, just that one processor. Provides higher level of abstraction from the underlying processor. You don't have to deal with allocating memory. I expect that hardly any students wrote that on their exam paper, but there it is on the mark scheme, just in case anyone did. I think go for these first ones. Alright, tick in the box. A programmer uses a high-level language and an IDE to create a computer game. IDE includes a translator, such as a compiler and interpreter. Tick one box in each row to identify whether the statement describes the use of a compiler and interpreter or both. Okay. Well, they both translate high-level code, so that's going to be both. Produces an executable. Compiler. Program needs to be translated every time it's run. Interpreter. There you go. 3 easy marks. Now we've got another tick in the box. Identify whether each statement describes a low-level programming language or a high-level programming language. The same language can be used on computers that use different hardware. High-level. It allows the user to directly manipulate memory. Low-level. It allows the user to write English-like words. High-level. It always needs to be translated into object code or machine code. High-level. And there we go. 4 marks. Object code is just like, it's like code that is very close to being able to be run on your computer, if you think of it like that. Alright, so complete the description of programming languages and translators by writing the correct term from the box in each space. Jack writes his program in a high level, would it be? I would have thought. High level language needs to be translated into assembly or machine code before it can be executed. It's done using a translator. One type of translator is an interpreter. This converts one line of code and then executes it before moving to the next line. It stops when an error is found. A second type of translator is a compiler. The code will not run until there are no errors. Now what's this? The something file produced can be run, blah blah blah, the compiler. That's hard. So not that many people would get that last one. I think the executable file produced can be run without the compiler. Let's see. Yes. And that's it. I hope that helps with that last chapter. You will get some questions on it. They can hardly ask. There's only a few things they can ask. Benefits of low level and high level, features of high level and low level, features of an IDE, purpose of a translator, difference between a compiler and an interpreter. That's it. So as long as you know that, you're going to get some marks.